All right, lovely people, let's have a look at probability problem. Here we have a problem. It says, suppose that you have 3 oranges and 4 apples in a box. Use a tree diagram to determine the probability of randomly selecting 2 oranges. And the second question is randomly selecting an apple and an orange. And then the last one is at least 1 apple. We will look at this, we will sketch the tree diagram, and we will look at double options, all the options involved. I'm going to deal with the first approach, and then I will deal with the second approach. The first approach is you have to look out for what instruction they've given you. If they are asking you without replacing, then it has to differ to when they are asking you that the first one was replaced. So first things first, I'm going to look at the case of these things being replaced. Using my tree diagram. Replace means when the first orange was selected, it was placed back before the second option. So for us, we have a tree diagram here representing the 2 events that have occurred. The 2 events that have occurred here is we have oranges and apples. Now, first things we must do is to add up all the number of items. We have 3 plus 4, so we have 7 items. We have 7 items, but 2 unique. So we have orange and apples. In all, we have 3 oranges out of the 7, and we have 4 apples. When you are drawing your tree diagram, it must be labeled. Now, why do we have 3 and not 1 when we draw the first orange? Because the first branch always represents the first action. Why do we have 3 instead of 7? We don't know the particular orange that we are drawing, because they said drawing an orange and then the second one. So we don't know, out of the 3 we don't know, so we consider the 3 of them as what we are going to draw. So if we draw, select the second one after the other. That's the scenario here. So the first orange we are selecting, we have option of 3. We don't know which one, so we consider the 3. The second, if we replace it, this is the first action. To have our second action, if we have replaced the first one, then we have a second branch. For this second branch, remember, if we are selecting something from the box, we don't know what we are going to select. We have apples and orange. So when we dip our hand, it could be an orange, it could be an apple. So what happens here, if we selected an orange in the first one and replaced it, the second action could also be an orange or it could be an apple. If from the first draw we selected an apple, the second draw could also be an orange, or we can select an apple. So these are the double action we have taken here. The double action we have taken here. So because it was replaced, we still have 7 items. If we take one and replace it, we still have 7 items. Still 3 oranges, still 4 apples. So we can go and still stay down. We still have 3 out of 7 oranges, and then 4 out of 7 apples. Here, if we chose an apple in the first place and place it back, we still have 4 apples, 7 items in all. So we still have 3 oranges and 4 apples. Now, because the action was performed twice, that is the arrangement here, 2 oranges, an apple and orange, that means it was done twice. We have to write out our possible outcome. So the possibility here is that we have drawn an orange in the first one, we can also draw an orange in the second one. We can also draw an orange in the first one and an apple in the second one. If we draw an apple in the first one, it could be an orange. An apple in the first one, we can also have an apple in the second one. So these are our possible outcomes. These are our possible outcomes when we draw items and replace them. Now, how do we present them and use them to answer this problem? Remember that the probability formula says that for an event to occur, for probability of an event to occur, It has to be the number of favorable outcomes. Number of favorable outcomes means things that can actually happen for that event over the total number of things that can happen. For instance, if we toss a coin, the probability we can either get a head or a tail. So the probability is the total number of outcomes is 2, the head or the tail. But at every point, you can only get one. We can't get a head and a tail at the same time. So favorable outcome is the one out of the 2. The probability of raining today is 60%. That is favorable outcome. What is general? 100%. That is the total number of outcome. So here we use number of favorable outcome over total number of outcome. Now they asked us the probability of getting 2 oranges. What we go is we trace that path. We have orange, orange. This is the only outcome that will give us 2 oranges. We trace the value of that path. We have 3 over 7 from orange and times 3 over 7. So we have 3 over 7 times 3 over 7. Now we give us the probability of randomly selecting 2 oranges, and we have 9 over 49. 9 over 49. That is the first one. And the second one is asking us the probability of getting an apple and an orange. We have 2 possibilities here. It could be apple before orange, it could be orange before apple, or it could also be apple before orange the way it's presented. Just let's take this. If it is apple before orange, then we have this condition. So if we check, then notation-wise, we can say probability of apple orange. In this case, is orange orange. These notations are very important. Now we trace apple is the first one. That's 4 over 7 times orange, which is 3 over 7. And this will give us 12 over 49. That is the probability of getting an apple and an orange. Now let's take the last one. Let's wipe some of this place. Okay. Okay. Now the last one says at least 1 apple. At least 1 apple, it means apple must be involved. Even if you drew the first orange, the second orange, or whatever, apple must be involved. So the only one that doesn't have anything to do with an apple is orange, orange. Remember that the probability of everything sums up to 100 or 1. So it means everything, the whole 100% minus the one that has nothing to do with apple, because they say at least 1 apple means 1 or more. So in this case, if we take out, there's a formula for doing this. We can say probability of not orange, orange, because every other thing is involved except orange, orange. And because the whole thing is involved, we have 1 or 100% minus probability of orange, orange. And in this case, we will have 1 minus probability of not orange, orange is 49, 9 over 49. And this will give us 40 over 49. When we come back, we will go through doing this same sum using a case, or the case where it is being replaced after randomly selected, or the case where it is not replaced after randomly selecting the item. Please remember to share this.